Okay, so chapter 4 is on forecasting, and we look at how methods of forecasting, why forecasting is important, and how it relates to operations management. Because when we want to plan our service, our production, we need to have some forecasting. Okay. So what I'm going to do today is explain about forecasting to you. I mean, you should be able to explain forecasting and the 3 time horizons that is used for forecasting, the type of forecasting. So basically, we want to start by understanding what forecasting is. Then we will look into the models or the methods for coming out with forecasts. So there's 2 main methods. One is the qualitative. So there is 4 qualitative methods. And the number 3 here is the quantitative method. So I will explain to you afterwards what we mean by quantitative. Okay, quantitative. And you probably will have an idea as well. I will ask you what quantitative is as well. And we'll look at how to measure accuracy of our forecast. Okay, so forecast is important for anything that organization or businesses do, especially in operations. The rest of the things that is in the book, I let you to explore yourself if you are interested. Okay, if you're interested in trying to explore especially the mathematical model, very very detailed mathematical model, but it's very interesting. Statistics is very interesting. How many of you like statistics? Statistics do you know statistics? Mathematics and statistics. ちょっと日本語では何ですかね。Akiko, statistics 日本語は何ですか？
統計。
統計。
Yeah.
統計工学。
Mm.
So, any one of you I love 統計。または、まあまあね。Miho-san, Miho, have you studied 統計 before?
Not yet, but I like maybe study. I can say okay.
It's interesting, okay, because especially today when you talk about artificial intelligence and also digitalization, industry 4.0, so it's very important. Okay, never mind. It's okay. So let's begin by looking at this case given in the book. It's actually forecasting provides a competitive advantage for Disney. Okay, Disneyland uses a lot of forecasting tools in order for them to plan their activities, in order for them to determine the opening hours and so on. So if you read here, there's a lot of things that, and it's a big investment, so they need to actually have good plans. So Disney generates daily, weekly, monthly, annual, and 5-year forecasts. So they have a forecasting system, and it is used by many, in the management, the maintenance, the operations, the finance, and the park scheduling, in order for them to meet their, targets and customers. And forecast is used to adjust opening times, the rides, the shows, and the staffing levels, and the guests admitted into the what do you call theme park. Okay, so you read about this, and you'll see why they are competitive. Why Disney is very successful? Because their forecasting system, one of them is their forecasting, and of course marketing and so on. But forecasting is the first, and it says they use judgmental approach. They use economic models. They use moving averages. If you look, we will have the opportunity to look at some of these methods. Okay, some of these methods that is going to be useful if you do research in this area. So before we go further, just a quick, as usual, my question to lucky person today: what is forecasting? What is forecasting? Miho-san, you are my lucky person today. What is forecasting?
Me?
Dayogo.
My
What do
forecasting?
you
Me?
think? What do you think? What is forecasting?
For focusing for about what?
Your opinion or
Mhm.
your understanding. What is forecasting? What is forecasting?
Forecasting?
Forecasting wa nan desu ka?
予測 予測
Yosoku.
うん
Yosoku wa do you imi desu ka?
予測 forecast
Forecast.
forecasting
Okay. Another word for forecast. Okay, Akiko, what is forecasting?
Predict the future.
Predict the future. The word is predict the future. Okay, but predict it is the art and science of predicting the future. You see, it has art, art and science. It's not just science for a mathematical model, but it is as art as well. And because we want to predict the future, so we need to actually have may involve historical data. You understand historical data? Nani, historical data, I put here already, example past sales. Tatoiba ne, onigiri, semua onigiri. Onigiri, I want to sell onigiri in 7-Eleven. And the place is in Shibuya. Okay, so I want to know this particular 7-Eleven, how many sale last week or last Monday, Tuesday, Thursday. So I want to make how many for tomorrow. Understand? So that is historical data about sales, because sales is actually demand. How many cars is needed to be produced by Toyota? Okay, Toyota makes sorry, this is okay, this is not bothering me. Toyota sells car. How many needed? How needed? They need to historical data and predict. Predict means how much, how many to make, and then adjust. So what's the use of prediction? Example is the future demand. Why we need for prediction? In this Disney World just now, what they use for prediction? What Disney they do some prediction of customers coming for next week is Raishu Golden Week ne. Okay, Golden Week. So Disney Tokyo predict how many thousand customers will come on Monday, Tuesday. So if they have this number, what can they do? What do they do with this number? Akiko, what do they do with this number?
They will use the data last year's data between Golden Week, the number of sales, the number of customers.
So they know opening hours, and then which game to open, which shows to open. So they can predict. But in production, for example, the onigiri production, we need to, because it's a basis of all business decisions. Okay, a lot of business decision based on forecasting value, production quantity, inventory, how much to keep, how many people to work, one shift, how many people, and then capacity. Okay, so this is only very there is time frames. Okay, so after this we'll talk about time frames. Okay, so there's a lot of many uses of this forecasting. Scheduling also is also important. So when you talk about forecasting, we are going to run away from talking about time horizons. How long do you plan ahead? Dono gurai you plan a company. Dono gurai. You plan 1 day, you plan 5 days, you plan 1 year. So this is horizon. Okay, horizon. So it must be broken. Okay, you have any idea when companies, when they big company, the time horizon for forecasting and planning? You have any idea, any opinion? The name of the time horizon?
Quarter.
Quarter. Okay, quarter is how many months?
3 months.
3 months. So 3 months, is it long time or short time?
I think it's short time.
It's a bit short. Okay, short time. Okay. So you have short time. Okay, Sarah, any other time horizon that you can think of?
3 months to 3 years.
3 months to 3 years. So 3 years, after 3 years, what do you call it?
After 3 years.
More than 3 years, more than 5 years?
More than.
Yeah. So what horizon is it?
Long range horizon.
Very good. Okay, very good. So I want you to start thinking about this time horizon of forecast or even planning. You can talk about planning, forecast, but many things that we have to do, we have to have short range. Okay, just now 3 months, quarter. Okay, so anything up to 1 year is Mijika yo. Up to 1 year, generally less than 3 months. Okay, this is a short range. So purchasing, job scheduling, how many workers level, job assignments, production level. So this is short term. We have some tools and also techniques that we can use for short term. But we have also the medium term. Now you start thinking, because you mentioned about long term. Therefore, there will be some. Do you know medium term? How long is medium term? So how long is medium term, medium range, do you think?
3 months to 3 years.
Yeah, probably 3 months to 3 years. Okay, depend on the company as well. Okay, depend on companies. So anything that 3 months to 3 years is when you plan for your sales and production planning for new models, your budgeting, capital budgeting, and so on. Okay, and of course the other one is long range, which you mentioned just now already. More than 3 years. Okay, more than 5 years. New product planning, new facility location. So these are all operations issues that must also be decided, and it depends on your forecast. If your forecast is growth, for example, you produce cars and the market is growing in China, and you want to actually build a new factory, or even R&D, research and development is long range. You develop new electric battery long range. So you want to develop better batteries. Okay, so that is the time horizon. So how long do you plan ahead for your working? Miho, how long you plan? What is your business plan?
5 years.
Okay, so you have long range plan. Okay, but because of COVID, what happened to your plan? Because of Corona, what happened to your long range plan?
Yeah, we have to reduce forecasting.
You have to reduce forecasting. You have to adjust and change. Okay, good. Okay, so this is the forecasting time horizons. Any question? Clear? And there are so many types of forecasts, but in this class, we're not going to talk about economic forecast. This is not economic forecast class, okay? In operations, it's more of demand forecast. In operations, our focus is here. Okay? Of course, in big companies, they have economic forecast, which is actually business cycle. Especially today. Today we are with Corona, so nobody can forecast 1 year. 1 year. Tabun 3 months, 5 months. Karena ini mana very uncertainty. Uncertainty. Okay, I just mentioned to you. Do you know VUCA? VUCA. Today, our life is volatile. Many things are volatile. Volatile means you check the English afterwards. Uncertain. So economic forecast now is not very good actually. And then volatile, uncertain. I think this is complex if I'm not mistaken. And this is ambiguous. So you Google this. You Google this. Inflation is increasing, and then economic growth is slowing. So a lot of economists actually doing this. Economists, they forecast for economic things. And of course, you also have technological forecast to predict the rate of technological progress and new products, especially digitalization. But we want to focus more on predicting sales of existing products and services. We want to actually more of demand forecast. Right, clear? So I'm going to straight go into what the book actually gave a suggested steps. Some people can create their own steps, but this is the basic steps, okay? So you want to determine the use of the forecast. That's why if the use is only for demand, then a simple method is useful, can be used, is necessary or not necessary, it's suitable. So you must understand what is the use of this forecast. If it is very complicated, then we have to use statistics and other more highly advanced method. And select the items to be forecasted, number 2, and determine the time horizon of the forecast and select the forecasting model. So we are going to look at this, selecting my main talk, my lecture or learning for you is forecasting models. Okay, what kind of forecasting models there are for demand forecasting? Gather the data, that is something that we need to do, and then make the forecast and validate and implement the results by checking the accuracy of our forecast. So the model can change. The model is not fixed. It can always, it's dynamic. Business is dynamic. Business is not static. Of course, we have to be aware that these are the forecasting issues. The realities is that forecasts are not perfect. Perfect forecast. Of course, there is a saying, it's better to have a poor forecast, a bad forecast, than not having any forecast. Better to have poor forecast than no forecast. Better poor forecast than no forecast. So they are not perfect. Of course, there are many things which will be outside the factors, and most techniques use assume that there is a stability in the system. Okay, we are getting the demand from a stable system. Who can predict Corona in 2020? Anyone? Dari mau kah? Cannot. So the the assumption was stable, okay? But when there is a disruption, then you need to actually remodel. And then another important thing to understand is that a product family, meaning that a product has many, for example, cars. Cars have sedans. For example, if Toyota, they produce different models. Camry, they have, I don't know, in Japan they call it, but here we call it Vios, they call it Corona, Altis. That is a product family. And you get the aggregate forecast. That is more accurate than individual product forecast. So think about that. Think about that. That means you better have an aggregate forecast. That means the total. Not have individual, because individual will have actually some changes. And individual, we can be flexible to change, especially if you produce different products. But of course, you only produce one product, then that's the only product that you can forecast. And it's easier, basically, if you have one product. Okay. Now, then we go to the methods. Because I need to spend a lot of time on this method. Now, there is two methods. Immediately, I've shown to you the quantitative and qualitative. Okay. So what is quantitative meaning? Quantitative. When we say quantitative methods, so what does the method will entails or consist of? Sarah, what do you think?
About quantitative and qualitative.
Yeah, what is the first one is quantitative. What do you think quantitative methods meaning of it?
Quantitative meaning is how many?
How many? Yes. How many? So it is based on numbers.
Yeah.
Based on numbers. Okay. And versus qualitative. So qualitative is not numbers. Not numbers. Do you study in research method subject in research in Meiji? Do you study qualitative methods for research methods? Because in research we have qualitative and quantitative methods. One is qualitative, one is qualitative.
Like interview or something?
Yes. Like interview, like, so when you get interview, does the person who respond to you give numbers or not?
Maybe not.
Maybe not. So what does he give?
They give me their emotions or their thinking or their value.
Yeah, their opinions. Their
Yes.
opinions. We are gathering opinions. So any quantitative methods uses mathematical models, data, or even variables associated, regression, for example. Okay, and qualitative, when the situation is vague. Okay, vague means, what's meaning of vague? When the situation is vague, wa wakaru ka? Then you use qualitative, because it's intuition, emotion, feeling, opinion, and the values that the person have. Vague wa wakaru ka? Vague. Miho, vague, kita kotaru ka?
Value? Situation is value. Value?
It's pronounced vague.
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 Have you heard of vague before?
Unfortunately, not.
It's okay. Akiko, have you heard of vague before?
Yes, and the meaning of is ambiguous, kind of.
Ambiguous, exactly. Ambiguous or not clear. Miho, not clear. Okay, Miho. Vague means ambiguous, not clear. It's transparent. It's not solid. Okay, it's transparent. Okay, it's vague. And little information is available. So when little information available, you go for qualitative methods. Okay, right. So we'll go into these methods one by one, those which I want to introduce to you. So we'll start off with the qualitative methods first. So I picked this up from from the slides, and I'm not going to add anymore. Okay. So there's 4. One is the jury of executive opinion. So this is opinions. It involves small group of high-level experts and managers. You want opinions. If you want opinion, you want to actually get from experts and also someone who has knowledge about the issue or the problem. Okay. Combine group estimates demand by working together. They can also sometimes, but this is not, it's very difficult. Statistical models that actually they can get some quantitative analysis as well if the interviewer responds to quantitative questions. Okay, so it's a group relatively quick, but the disadvantage is that it's a group thing. So it's probably going to be everybody agree on just one opinion. So it's not going to be what do you call consensus. It's going to be consensus. Similar to Delphi method, which is also opinions, and it is an iterative group process. Iterative mean you do it few times. Round 1, then round 2. In fact, Delphi method is used in a lot of research as well. Okay, a lot of business research uses Delphi method. So the decision makers evaluate staff, administer the survey, respondents, records who can make valuable judgment, and so on. So we repeat this. Okay, decision makers, the staff doing the work, or the respondents. And the third one is a sales force composite. So each salesperson projects his or her sales. So again, this one, this give numbers. This give number, but it's like opinion. Okay, we bring all the sales people. Now, what do you think the sales next year is? So the sales, he knows how much he can sell. He said, okay, I'm going to sell, this amount. Then they total up. So this is sales force composite combined together, combined at national district level, especially what do you call, because they know customers wants. If specific, this is a very specific product. Okay, so you can use Salesforce or composite. Can be overly optimistic. Optimistic means, you are the sales and say, okay, next year 20. Last year I sell 10. Next year 20. So another guy will say, okay, I can go 50. So you add them up. Oh, next year we can achieve 1,000. Last year we only sell 600. Okay, can we? So that is, can be overly optimistic. That's a bit, the disadvantage of, because qualitative method. But of course, the thing is that if it is vague, okay, vague and you are uncertain. Product development, they use a lot of qualitative methods initially when they want to develop products, like cars, for example. They will ask consumers, okay, what kind of design do you like? They'll show some figures, some images, and say, okay, we want to go for this. So they go for sports design. Okay, so they can use this method. Okay, and that is market survey. Market survey will ask consumers about purchasing plans, and this is useful for demand and product design and planning. So what consumers say and what they actually do, of course, may be different. So it's not exactly the same. but it is a useful feedback that you can actually put in, especially quality issues, quality problems. You can get customer can do a market survey to find out. And again, it can be optimistic as well. Okay, so but normally when you do these qualitative methods, you still need some kind of procedure to go through it. You need interview forms, like Sarah said, interview. So where's the interview form? If you don't have interview form, interview form, interview questions. If you don't have interview questions, how are you going to get the response? So you cannot just ask random question. Random, any question comes, you cannot. It must be structured and specific. Okay, right. Any questions? These 4 qualitative methods that is used to actually predict demand. Okay, predict demand. Questions? Any questions? Okay, if no question, then we'll move on to the quantitative methods. Okay, so I promise myself I'll be very slow with these quantitative methods, so that if you stop, please stop me anytime. So quantitative methods, all methods that is quantitative uses data, uses number, especially demand, past demand data or sales data, or some dependent variables data. Okay, dependent variables mean we want to predict sales based on the age or based on the region. So these are associative models. I'm not going to. I will just show to you. Okay, the models, but it is a bit complicated. Not to say difficult. It is a bit complicated. So all this, the first one is when you talk about quantitative, one is the time series models. Time series models. What is time series? When you say time series, sure. What is time series?
Time series. I think it's use a series of past data and do the forecast.
So it uses a series of past data. Can you give me an example of a series of past data? Can you, for example, tell me a series, the time unit? The time unit.
For example, Disneyland about the past 1 week. Every days.
Days. Okay, right. You're right.
Number.
Right. So Monday, Tuesday, Wednesday, Thursday. So week. Okay. So how many weeks? How many days in a year? So you can plot the graph daily. Can you plot the daily graph like COVID now? COVID, Meiji no time series model ga arimasu yo. Meiji time series. Meiji. So you can understand this technique that uses a series of past data. Okay, so it's actually this 4. Naive approach. Don't worry about the the English. You can see it's very simple actually. The bit difficult is this trend projection. I'm not going to explain much on this too, but I want you to have a feeling. That's all. Okay. After that, we can if you are interested, you can explore further. So naive approach. Moving averages, a lot of being used in stock markets. Okay, moving averages, exponential smoothing also, trend projection, trend projection. So these are the 4. So one more. So what's the one more? One main one, which is actually related to what we call as associative models. Associate. So it's not just one number. Because time series is just one number and you plot the graph. Okay. For example, a number of COVID cases, number of deaths. So it's just one. But when you associate, kanke ga arimasu ka? Death and vaccine, and so we want to model that. So associate, we combine the variable. When we combine the variable, when we incorporate variable that might influence the quantity that we forecast, then we say it is associative model, and the main one is regression models. Linear regression, multiple regression, so all the regression models. If you have seen y equals to alpha plus what do you call m plus alpha x1 plus beta x2 plus, so that is the regression model. Right? I'll show you to you. I'll just briefly show you if we have time. But before we go further, any time series forecasting, when we plot, we will plot the graph, because we can see, or if we don't see the graph also, we can see that there are four main characteristics. Behavior, we call it behavior, which is trend. Trend means up or down, okay. Ima wa COVID no case Nihon trend wa up, down. Miho, shitemasu ka?
Trend down now.
Down, good ne. Very good. Malaysia mo down your trend down, down. Okay. So trend, same thing in demand. There is uptrend. For example, the trend for going to holidays. Okay, going to go upwards during the golden week. After golden week, it go down back. So it's a trend. Season. Is there a season? For example, in a day of the week, every week, which day is higher sales? So day of week. Day of week, for example, every Tuesday, good sales. So that is called season. Or week of the month. Week of the month, first week of the month, good sales. Why? Because everybody got salary. Everybody got pay. First week of the month, high sales. And then that is season. We call it season. Or cycles. Cycles are affected by environment and so on. So this is you can see these components or behavior in all time series. Okay. Market, stock market, like this lah. Stock market, cycles affected by environment. Random random blips in data caused by chance or unknown reasons. Okay, so random, a bit difficult to understand, but this is the components of demand for time series forecasting. Okay, and you can see here, you can calculate the average demand over 4 years. Okay, you can calculate, you can see average demand over 4 years. That's why people can do a lot of prediction. But today it is much more easier because internet and also social media and also online buying. So online buying, immediately data come. So Lazada or independent Amazon, or in China, China, the online commerce seller online in China. What's the name? What's the name of the big Amazon in China?
Big sale in named Taobao.
Taobao. Oh, other than that,
Taobao.
Jack Mia Magic. Anyway, so you can get data immediately because of everything is here already. Everything is in the online, so capture immediately. Right. Okay. Remember just now we talked about 4 types: naive, moving average, exponential, and trend projection. So naive approach is a technique. Naive means like like stupid, okay? No, not stupid, it's naive. The technique assumes that the demand for the next period is the same as demand in the most recent period. I mean, if January sale is 68, then February will also be 68. If today is 50, tomorrow is 50. Sometimes small businesses is okay. It is workable. It can be a good starting point. It is cost effective and it's efficient. Now, so what is the forecast for? Okay, Akiko, what's the forecast for week 5? Okay, week 5. So if I use the naive approach, what you forecast to be the sales in week 5? What is here? Akiko.
9 or 10.
Miho, 9 or 10. Okay, so that is a guess. Okay, we says here you assume the next period is same as before period. Week 5 before period is okay. Miho, week 4. So what is your forecast for week 5? If I use naive approach.
Naive approach, maybe 10.
10 ka.
What's naive?
Because it says here, naive approach is the demand. This assume it will assume that the demand in the next period is the same as the demand is the most recent period, the period before that. So if January is 68, then February is also 68. If week 4 is 12, then week 5 is
12.
Okay, Karuka. So it is actually before period. What about week 6? Shu.
Yes.
What do you think the forecast? Now I'm trying to fill up this blank here. I'm trying to fill up this blank. This is the forecast. I cannot do the forecast for, of course I can do forecast for all this, but I'm not going to do. I'm asking you, what is the forecast for, I mean, I can also ask you what's the forecast for week 2. What's the forecast for week 2? So, yeah, now you can get it. Okay, so it is.
It all comes same.
It won't be the same. It will be the previous period. The previous period for week 3 is week 2. It will become 8. So week 4 is going to be 9. This is the sales. Okay, this is the actual demand. So week 5, 12, week 6 is going to be Akiko. Wakaruka? Simon, any questions?
Yeah, I understand.
Okay, that's why it's called very stupid. Very straightforward. Very standard one. Primary 1 student also can do. Your son also can do. Miho, your daughter 6-year-old also can do this. Okay. Right. So naive approach. So, but it's used. It's used. Companies or small businesses still can use this. Right. Oh, battery low. Now we go to the next one, which is actually moving average. Now, this is widely used. Even though it is quite simple, it is actually widely used. No problem. It is actually arithmetic. So when you say average, moving average, it is actually a forecasting technique that uses the average of the n most recent periods of data to forecast the next period. So I need to have for example, if n is equals to 3 and the time is days, so I need 3 days data. If it is week, I need 3 weeks data or 3 month data or 3 years data. N is the most recent period of data. Okay. You can only use if little or no trend. And often it is for smoothing purposes, means you try to allow, continuity in the data. Provides overall impression of data over time. It will show, okay, it will just show a series. That's why it's called a time series. But the method is, you don't use the previous data only, you predict using some data, previous data, and depends on how accurate you want, okay? If the old data, okay, the formula is this, moving average is the sum of demand. So you know this symbol, right? This is sum, Akiko, kore wakaru ka?
Sigma.
Sigma.
Yeah.
Okay. Total, sum of.
Okay.
Sum of. Sum of. So total sigma of demand in previous n periods divided by n. Very simple, straightforward. Okay. This is the moving average. But of course, the next period will take the next 3 data. The next 3 data. If you use n too big, for example, I want to take 12 years before. So why we use the latest data? Why we use we want the recent data? Obviously, you want the recent data because recent numbers is showing much more accuracy. Right. So n is the number of periods. For example, 4, 5, 6, 7, whatever. Not months only. It can be weeks. It can be years. Only years. Okay. It can be years, or it can be centuries. A century cannot. Century. Too long. Naga ini. Naga sugiru. 100 years. Okay. We'll do exercise. Now, so all of you try this. Calculate the forecast value for week 4 and week 5. Okay. So I give you like 3 minutes, 4 minutes. So you got the answer already, Sarah?
Yes.
So don't tell me the answer. Tell me the workings. The workings.
Okay. 15 plus 20 plus 10 is 45. And divided into 3. And it could be 15.
15.
Yes.
Did you get the same method, Miho? Did you use the same method?
Yes.
Sure.
It's actually the same.
Exactly the same. Akiko, exactly the same.
Yes.
Yes. Okay. So you can do that for, okay. So these 3 data needed for this forecast. So sometimes we call this symbol FT, FT. Forecast for time. Time is 4. So this is forecast 4. Just symbol, okay, just symbol. So this is 15 plus 20 plus 10 divided by 3. Why? Because I say 3-week moving average. So for the next one, okay, sure. Week 5. Tell me how you're going to.
Yes. 10 plus 20 plus 10 plus
not okay.
18.
So this one, So
Yes.
this one
and divided the 3.
Then you can do for the rest. So if it is n equals to 2, for example, if I say find, if n equals 2, I can find week 3. I want F3. I'm challenging you now. Okay, Miho, F3, n equals to 2.
15 plus 20 divided into
F3. Tomato kudasai. Koko.
yeah. So n equal to
okay.
so 15 plus 20.
Hi. 15 plus 20 divided
in 2.
Okay. So you understand that concept. Okay. So that is moving average. Moving average is simple. So we move on to okay. I'm not going to ask you to do this. I think you already know. So this one we can actually. I wanted to ask you how to forecast for next January. That means this January. So I think you will be able to do it. Okay. You can do this after class if you want. So let's move on by looking at some issues of moving average. Okay. Moving average is not very accurate because what you do is only take the numbers and you just divide it by the 3 numbers. It is not. So use when some trend might be present. Older data usually less important. So why don't we use weights? Weights is actually some additional, weights on the latest data. That means I want to use 50% from the last month, and then 30% 2 months ago, 10% 3 months ago. So that is weightage. You don't want to give same weight. Okay, when we divide, and just now the moving average was same weight. Everyone is the same, but it may not be that accurate because if we assume that the latest trend and latest data is much more accurate, then we want to actually use that. Okay, so this is called a weighted moving average. So weighted moving average, don't worry about this so-called formula. The weight, what we need now additional is weight. That's all. The demand is still in the what do you call formula. Okay, we have that, and they divided by the weights. Sometimes we can divide by the n also can. Okay, let's look at the book example. But before that, the book gives this example. Okay, assign more weights to recent data. So the idea is to give more weight to recent data. So let's say I give this weights of 3, 2, 1, and the sum of the weights is 6. Weights are given in many ways. Okay, it depends on the product, on the company's policy, and so on. So last month data, very immediate data, 3. 2 months ago, 2. 3 months ago, only 1. So forecast for this month is 3 times sales of last month plus 2 times sales of, that means I'm going to break down into these 3 different weightage. Okay, different weightage, and divided by the sum of weights. So what happened is this. This is from the book, the same example. So the company actually has this data, actual shared sales, 10, 12, 13, and so on. So 3-month weighted moving average. So it uses 3 months, 3-month weighted moving average. So it is 3 times 13 plus 2 times 12 plus 10, okay, divided by 6. Okay, because 10 times 1 basically. So you'll have 12 and 1, 6. Rather than if you use moving average, okay, let me just quickly do the mathematics for you. 10 plus 12 plus 13 is equals to 35 divided by 3. Consider is 11.67. Okay, so there is if you use moving average, it is 11.67 or 11 and 2/3. So there's a difference. This is moving average, pure moving average. Okay, so the you can see that more heavily weighting the latest month provides a more accurate projection. Okay, so that's the whole idea of weightage. Any question? Weightage. This is trying to put in more, we want the latest figures to show in the prediction. Okay. Any questions? You understand? Very clear, right? It's very simple. Only thing, okay, if you read here, learning exercise. If the assigned weights were 0.5, 0.33, and 0.17, instead of 3, 2, and 1, okay, instead of 3, 2, and 1, we use 0.5. I found these results. Okay. Which is the forecast for January's weighted. What is the forecast? Sorry, what is the forecast for January's weighted moving average and why? There is no change. Okay, the answer is there is no change. These are the same relative weights because it is the relative weights. And you note that weights is equals to 1 now. So sometimes you see that weights are assigned according to these decimal numbers. Easier, much easier because you can add to 1, so that doesn't and it can think about how many percent, 50%, 33%, 70%, rather than 3 to 1. 3 to 1, very difficult to explain. Okay, but percentage is much easier to explain. Okay, right. I think I've already explained to you this moving average, weighted moving average. The next one is exponential smoothing method. It is also, taking the average as well, but it is trying to improve moving average, not able to actually giving accurate forecast. So when you use exponential smoothing method, if you look here, forecast, or we call it new forecast, new forecast, that means the next period forecast. The next period forecast is last period forecast. For example, this is, I want to predict January. I have December data. Okay. So I need last period forecast and I need last period demand and also the difference between. So this is taking care of the difference. Actual demand minus forecast is the alpha difference. But the thing is, there is alpha, which is what we call a smoothing constant. A smoothing constant is actually taking into consideration the difference in the value. Okay, it's a smoothing constant. It's something like a weightage also. Okay, and normally the numbers is from alpha is 0 until 1. No more than that. It can be 0.5, can be 0.1, and so on. Okay. That means we're taking 10% of difference into the new forecast. Okay. So in term of formula, Ft equals to Ft minus 1 plus alpha multiply by actual previous minus forecast periods. So this is the formula. Nothing fancy about that. Nothing difficult. Okay. Let's look at just one simple example given in the book. So the predicted demand for this so-called car, okay, is 142 from Ford Mustangs. But the actual demand is 153. The company has provided a smoothing constant alpha of 0.2. Okay. So just use this formula to actually predict for future. That means Ft, right? Ft, or the next period forecast, is 142 plus 20% of the difference. So 153 minus actual demand minus predicted demand of the previous period. Okay, this is the actual. This is forecast. So forecast plus 0.2 of this difference. Okay, and you'll get 144. Right. So you can do this, and you can actually incorporate this, and you can find for. So it's called exponential smoothing method. Exponential smoothing method, and there's a whole bunch of much more what do you call alpha. They can give different alpha. You can see the difference between giving different alpha and so on. So this is exponential smoothing method that is also been used to forecast. Any questions? I'm not going to go beyond that. I think that is the, because it's going to be a bit more exponential smoothing method. Okay. Any questions? Yes.
Question: How
Yeah.
does the company decide the alpha number?
How does what is alpha depend upon?
Yes.
So basically, you want to give when alpha is high, okay. For example, so if alpha is 0.8, what is the difference here? Let's say the difference is 10. So if I use 0.2, if alpha is 0.2, then I am going to add 0.2 of 10 is actually
2.
2. If I use alpha 0.8, 8. Okay. So thus sometimes if alpha is too big, okay, because you don't want to assume that whether the differences is because of a trend or because of just chance causes. Okay, so too high also will result into overly optimistic number. So normally alpha is normally less than 5. Okay, 0.5, normally less than 0.5. So in the range of 0.5 to 0.05 is written in the book on page 155. Okay, I don't have this. Okay, so it is range from 0.05 to 0.5. Normally, it can be changed to give more weight to recent data. When alpha is high, what it is meaning is you're giving more weights, more data. And when you are giving weight to past data, older data, the alpha is low. Okay. So it depends on the company's policy. Okay, so understand?
Thank you. Okay.
Okay. Now, how do we actually know our forecast is accurate or not? Do yate, how we know? So of course, in quantitative, quantitative, anything must have formula. Very simple. Because in quantitative, how accurate? Then I need a formula. I need to find the difference. I need to find the accuracy. So there is a method of measuring the accuracy. So we want to compare basically the error between the actual and the forecast. So we want to compare the forecast values with the actual value, right? So if I have a method to measure that, I can actually determine whether it is accurate or not. So forecast error is actual demand minus forecast demand. So that is what we call as error. But there are methods to actually determine. I'm going to introduce to you the method for determining accuracy, okay, of our forecasting method. So common measures of forecasting errors, determining errors is actually three. Is being introduced in the book. One is called mean absolute deviation. So mean absolute deviation is actual minus forecast divided by n. Okay, so the sum of all your data divided by n. So this is called mean absolute deviation. So you can do that for your moving average or your weighted moving average. You can also use mean squared error, okay, which is actually again forecast errors. Okay, forecast errors. We look at an example. Okay, mean squared error means squared sum of forecast error squared divided by n, and mean absolute percent error, which is absolute value. It doesn't take into account negative. Okay, absolute 100 times actual I minus forecast divided by actual divided by n. Okay, so these three methods can be used to measure your forecasting accuracy, whether it is much more accurate. Then probably that's how also companies determine alpha. Okay, companies can determine alpha through the errors generated by the different alpha values as well. So you can change the alpha value and see whether it is accurate or not. Even in fact, the example actually shows how it's going to be done. Okay. So the first one, mean absolute deviation. If you, I'm taking from the example from the book. So it says here, mean absolute deviation. Okay. So during the past 8 months, this is what the post operation manager want to test the use of. Okay, this is exponential smoothing with a different alpha, 0.1 and 0.5. So compare the actual data with the data we forecast using each of the two alpha values, and then find the absolute deviation and the mean absolute deviation. Okay. So this is the forecast with alpha 0.1. This is the forecast for alpha 0.5. And the bottom here, which is actually the absolute deviation for alpha 0.1 and the absolute deviation for 0.5. The mean absolute deviation is the bottom number here. So all these numbers, you add up 82.5.45 divided by n. N is equals to 8. So you get 10.31. So the MAD, not math. In English, math is crazy. It's not math. You know the English word for math? The meaning of math in English? No, it's not math, it's MAD. So we don't say math, we say MAD. MAD, okay? So the MAD for, right, I cannot see you. Okay, never mind. You understand? This is using the formula, it's just, this is the absolute deviation. Okay, absolute deviation, which is different between actual and forecast, 180 and 175, which is 5, 168 and 177. So the lower the mean value, the more accurate it is. Okay, so in this case, 10.31 giving the lower mean absolute deviation is giving a better accuracy than 12.33. Okay. That's how we can actually compare. That means no point using alpha 0.5. No point. No point mean it's not giving us, you know, better answers or better predictions. So using alpha 0.1 gives us a better prediction. Or you can use n equals to 5, n equals to 3, and see the mean absolute deviation as well. You change. But luckily today, all these are actually in software. You can Google and go to the internet and just Google. All these are already here, but I'm teaching you the fundamentals, the basics. Okay, right. And the rest of the so-called measure of error. So mean squared error using the formula also. Again, okay, error is what do you call 5 squared. Actually, it's also deviation. It's almost a deviation, but the formula here is different. The sum of deviation squared divided by n. So in this case, 108.9. So a low MSE is better. So normally, when you look at this mean squared error, the lower the value, the better. Okay, we don't want a high mean squared error value. Okay, so that's why you can have a different forecast. You can forecast for alpha for different value or different methods that is being used. Okay, that is mean squared error. This is very common in statistics, as well as this mean absolute percent error. Using the same thing, it is putting numbers into the formula. Okay, putting numbers into the formula and find the measure. So this is mean absolute percent error. If it is, because it's percent, that's why it's in percentage, 2.78%, 4.46%, and so on. Okay, so in this case, using 0.1 is 44.71%. So you can do this for alpha 0.5, you can do this for alpha 0.3, and so on. Okay, so MAPE will show error as a percentage of actual values, undistorted by a single large value. So you read here, it is the error as a percent of actual values. It is not biased or distorted. Distorted means change by a single large value. What is MAP when alpha is 0.5? You calculate this, you get 6.7%. As was the case of MAD, MSE, the alpha 0.1 was principal for this time series as well. So you will notice that we can determine the accuracy or better forecast. When you say better forecast, all these measures, MAD and then MSE, MAPE will show low values. Okay, so what you do is actually you compare. You can compare comparison of forecast error from different methods. MAD 10.31, MSE 90, but yeah, it's lower. So using alpha 0.1 is much more what do you call accurate. You can also compare between the three different methods using the same formula. Okay, you compare with moving average, weighted moving average, what do you call exponential smoothing. But normally exponential smoothing will show a high level of accuracy. Exponential smoothing will show a high level of accuracy. Okay. Right. Any questions? It's quantitative. Quantitative, I know people don't like quantitative because it's cumbersome numbers. But if you like numbers, it's very interesting. Okay. Finally, there are other things. I'm not going to go. There's a lot of other. The trend adjusted exponential, trend projections. If you're interested, you can actually refer to the book. The other one that I'm going to just mention is the associative forecasting, which I mentioned early just now. When we started the class, this is associative forecasting. So if you read here, when something changes, okay, in one or more independent variable. Do you know independent variable? The difference between dependent variable and independent variable? Shitemasu ka? Independent variable. Independent variable. You must study this. You must learn in masters. Very important. IV. Maybe you know it's Nihongo and DV. Correct? Okay. X. So this is the Y equals to X, right? So this is the dependent variable, DV. You can have X1, X2, independent variable. For example, I just throw you example. High blood pressure. You know high blood pressure? Or sick, heart problem. Okay, sick. You get high blood because of eating, plus no jogging, plus. So this is the independent variables and will result into the response. For example, length of the material depend on this size, this size, this size. So many variables. So these are dependent variables. So we want to know the independent variables that affect the change in the dependent variable. For example, sales. Sales is depend on what? Depend on the characteristic of the consumer, the age of the consumer, where he lives, for example. Many factors. Okay, so not only one factor, many factors. And the most common technique is linear regression. Okay, so linear regression is, you will find a same like time series also, but normally we'll have this time, so linear regression. Why? We can predict y hat equals to alpha plus bx. Okay. So it is associative forecasting, and it includes multiple regression. This is just one singular regression. And okay, I think I have enough time to just mention about forecasting in the service sector as well. Not only for production. Many of the things we talk about is tangible products. Tangible. Of course, Disneyland is also not tangible. So service sector, it is actually much more difficult. Service banks, hospitals, okay. So that's why they have a booking system. They don't have they need to create the demand. So special need for short-term records needs differ greatly as a function of industry and product. Hotel is different from banking. They have holidays and other calendar events, and it is affected by unusual events. For example, fast food restaurant forecast. Percentage of sales by hour of day. So you can see the fluctuation. Lunchtime and dinner time. Mochiron. Mochiron. Katakana. So this is forecast for restaurant. Or call centers. Call center, FedEx call center. Morning, afternoon until this is the peak call. So peak call, you need to put 10 people on the answering tellers. Okay, right. So they have modeled this. Can model and can collect data, and this is statistics. This is Tokay. You can find data and use average and so on. Okay, right. So I have this before you go, just to Miru, Mianai, Miruka, Miru. This is textbook. What do you call slides? Okay, so you can go this. Oh, I wanted to show you this. So there is trend smoothing with exponential smoothing with trend adjustments. Okay, when a trend is present.
We're now watch your slides of chapter 4 now. So can you switch?
Miru. So this is the book slides. So I was mentioning just now, you can have, trend adjustment for trend smoothing, exponential smoothing, and a little bit more complicated formula. But put in the software Excel can do it for you. No need to do the calculator, do it in Excel. So you can do this. and trend projections, the least square method. I wanted to show you this multiple regression just now. The seasonal index. So these are all mathematical models. Too many, too much. And you can, if you're interested, you can go and look for the methods, which is this is one example. This is linear regression. To me, it's very interesting. To me, it's very interesting because you can see the trend, you can see the the average and the Y bar, X bar, and you can predict the sales. If X equals to some numbers, you can predict Y hat. They call it Y hat sales. You can predict. Prediction is science. This is science. The science of prediction. So you can predict the sales for next year. Okay, the payroll. If the payroll is 6 billion, you can predict that. Okay. More jika nggak narim, jika ni narimas ni. So it's already time. Okay. Any questions? You don't like this, I know. You don't like the standard error and all these things, but these are correlation. You can see correlation very negative, positive. Okay. Yeah, kokumade ka? Any questions? Taksan arimas ni. If you are interested, you can I can help you out to tell you what are the things that you can do, and you can use SPSS software. SPSS software. SPSS. If you have problem with SPSS software, I can also help you and try to design your survey and also how to do the research. Okay, I will have a nice golden holiday. Demo watashi no don't forget about the forefront. Please read the forefront case study. Forefront manufacturing. Sarah, forefront manufacturing. You know?
Yeah, the one which is from the Singapore University.
Okay, this one, right?
Yeah.
Okay. I give you some tips. Okay. So, and this is as asking you it gives information first about the output, okay, and also the prices of the sales, the price, and it gives you the labor hours and labor time, labor cost. At the same time, it didn't give you it gives only the multi-factor productivity is actually 2.2. So it is reverse. So multi-factor productivity is equals to total output divided by. So this is the basic formula that you must use. School in Malaysia. School. Heavy rain. Malaysia heavy rain. Okay, Sarah, are you listening?
Yes.
Total output divided by total input. So this is equals to 2.2. First, you must put this formula first because everything equals to 2.2 is given here. So what is the total output? Total output is the number of sealing type is 2, cassette is 4, this is 6, multiply by the price, that is your earnings. That means your total earnings is 2 times 350 plus 4 times 450 plus 6 times 500 euro, right? That is your output. value 2 times 350 plus 4 times 450 plus 6 times 500. わかるか？わかりますか？ごめんね、私の日本語は悪いね。あきこ、わかりますか？
Yes.
Okay, はい、わかりました。And then, so this is the average cost. So you need to, because cost is here, this is the cost of producing. But we don't know, we only know labor cost. But we don't know plus others, because others is multi-factor. Multi-factor is labor plus overhead plus capital plus, but it must be in dollar, euro. It must be unit the same, euro per euro. So labor you can calculate because ceiling time 1.5 hours per unit. So you must multiply to get the how many hours to produce. Then you multiply by the 40 euro to get the labor cost. Understand? So labor cost known. You can put the value plus X. X is unknown. You understand? X is unknown. Unknown because that is the other cost. Other cost for calculating the productivity. Okay. So what labor productivity for each type? This you can calculate. So average cost per exponential. You can also divide by. I think you can also divide by the number of aircon that you produce. Also can. Okay, you can also use that. Okay. What is the average cost per air conditioner? Sarah. Okay, you tell me how to calculate that.
Average cost.
Average cost. Okay, I think I explained for B as for C actually. I explained A is actually very straightforward, very simple. Okay, 2.
2, how to say, times.
2 times
350.
Okay, so the total value, right? The total output, right? Total value of the output. Okay. Maybe divide by 6 only, you get the answer. Not 6. Divide by 12 ka. 12 aircon ka.
12 yeah.
Tabun, that is the answer for number 1. Do you agree, Akiko? If I total all the price and I divide by the total output, number, just number, 6 plus 4 plus 2 is 12. So I get per aircon, which is probably the right answer. divided by 12. Divided by 12. For A, question A, A, calculate the average cost. A. So divide by 12. But for the third one, C, you have to do a little bit more calculation. Anyway, it's up to you. I'm not looking for exact answer. I'm looking at how you think. Okay. My approach is always like that. I will give you marks also if your thinking is right. But if your thinking is wrong, I won't give marks. I give less marks. I deduct marks. But if the thinking is right, I will give you marks, even if you do, wrong calculation. Sarah, you understand ka?
No, so difficult.
So difficult. Kangaite kudasai. You can discuss among you.
Okay, I'll try.
I think you should meet among you, and you should discuss and work together how you actually can solve this.
Oh, can you work together?
Yeah, why not? No problem.
Okay.
I don't. It's okay. It's your. You can work together, but you cannot just. photocopy and send the same thing. But if you work together, but you do separately. Every one of you can do you can ask question and discuss, but after that you do by yourself. Okay.
And how can we submit the answer
by email? By
oh,
email. This one don't submit
email.
in link. No,
Okay.
no link, no lines. Submit by email, please.
Okay, we will. I will.
Okay, so have a nice holiday. Take care, and I will see you 2 more weeks.
See you.
Okay.
Thank you very much.
Thank you.
Thank you very
Hi.
much.
See you.
Mata.
Thank you.
Take care.
Mata aimashou.
Mata aimashou. Hi.
Take care.
Take care. Okay.